Well, hello there. Whether you're watching in YouTube or you're watching in Twitch, welcome. This for me is my 56th stream, and it was a very late start today. I had a bunch of errands to run, and I was working on some sequence diagrams for yesterday, or that I wanted to have yesterday to show you guys. So sorry about that, and this is going to be a short stream because I have to get out of here by 2:45. So for me, that's an hour and 15 minutes. So let's see what we can do in an hour and 15. So I'm working on this class called Tls Decorator and finished it yesterday, but we have not yet integrated it into Rover, which is our web client command line tool. Rover has an experimental decorator in it that we use to make sure that I understood how to do TLS. And we're going to remove that old decorator, add the new one. And then for this layer called HTTP Client Network Transport, we will be adding dependency injection to it so that we can make it decorate its network connection with the TLS decorator. So I think last time, I had a little diagram showing where the decorator fits in. Our app being the Rover client here, and the decorator being here, and the operating system socket layer stuff here. I have a class called network connection, which is a OS abstraction layer for a socket. And this HTTP client transport uses a network connection and then provides the implementation of an interface called HTTP connection that the app uses. So the idea with TLS Decorator is it turns one kind of network connection into another by way of securing the channel using TLS, which is transport layer security. So basically it encrypts all data going out and decrypts all data coming back in. So right now, I'll go back to this diagram. This class here, HTTP client transport, constructs this network connection directly. So in order to insert this decorator, we'll need to take out the logic that creates this class and allow it to be replaced or augmented so that we create a decorator in addition to the connection. All right, and then I wanted to show you guys some of the sequence diagrams I made. This sort of goes to the last two streams. I put it under Notes, TLS Decorator. So I have 3 sequence diagrams here to show you. And I apologize if I don't have the UML syntax completely 100% pedantically correct, but hopefully this gives you the idea. So user, in this case, is the application, the user of the decorator. And then network connection is the underlying TCP connection that we want to run the security layer on top of. So it's basically to start up, there are 3 calls. There's configure, and then connect, and the connect calls the connect of the underlying network connection. And then process. Process is where all the interesting TLS stuff happens. So we first create a TLS config, then create a TLS context using client. So it's a client-side security context. Then we use TLS configure to tie the config with the TLS. And then we tell it to connect with callbacks. Finally, the process, the original process call is forwarded on to the underlying thing. So it's sort of following what you'd expect a decorator to do, is for calls that are part of the iNetwork connection interface. Anything coming in is usually forwarded with some changes or some additions. So connect is forwarded, process is forwarded. The other thing that our decorator does is it creates a worker thread, which we'll see in the next 2 sections. So in send, we're introducing this send buffer, which is a scratch space, so to speak, a queue. So when the user sends a message to the decorator, what the decorator does is it appends that message to the send buffer and then wakes up the worker, and then we return. In other words, the send is pretty much asynchronous. When the worker wakes up, it reads that send buffer and then calls TLS write to give all of that buffer to the TLS layer. And then it'll remove the data written to TLS write when TLS write is done. Actually, this line should move down to here because this is a synchronous call, so we don't actually remove it until here. So during TLS write, TLS will call our callback, and our callback receives the encrypted version of the message. So we send that to the network connection, it returns, and we return from our callback. TLS write finally returns, and then we'll remove the unencrypted. So unencrypted comes in, goes out, encrypted. And then that worker goes back to sleep. So on the receive side, it's the opposite direction. So secure message comes in to a callback, a delegate we've registered with the network connection. And by the way, that delegate is registered back in this process. So this process is called this network connection gets two delegates, one to call when the data comes in and another one to call when the connection's lost. So here it's calling, right here, it's calling the one when data is received, right? Secure data. So we append it to a receive buffer secure and then wake up the worker thread again and then return back to the network connection. So in the worker thread's context, when it sees data is in this secure message receipt, the receive buffer secure, it'll call TLS read. TLS calls the read callback. The read callback will read the secure data from the receive buffer and remove it and then return. And then TLS read returns with the decrypted version of that. That's given to this delegate that the user registered. It's the same type of delegate as from the underlying network connection, the secure message receive. This is sort of the decrypted message receive. And that returns back to the worker. And I guess I forgot the other thing. Every time the work thread's done, it goes back and waits again for the next thing to happen. So hopefully, if you look at my OneNote notebook, which is linked below, you can get a hold of this page, and hopefully it makes a little bit more sense, the call flow. You can see it looks pretty complicated, and that's what I was struggling with yesterday. I was creating mocks for this user, for TLS, and for network connection. So the one thing on the left and the two things on the right were being mocked, or what do you call it? Simulated. There weren't real TLS, there weren't real network connections. But because of the complicated work, the call flow, I was getting confused. So really I should have done myself a favor and written these up first before I tried to do the work. But now they serve to sort of clarify what I was doing yesterday and then documentation for this class if I ever come back to it. All right, so here's the order of operations for today. For the next hour, I'm going to remove the old Tls Decorator, which is an experimental decorator. I'm going to add the new one, and then we're going to have to add this dependency injection step because otherwise this class won't have been used. There will be no way for us to give the decorator to it. So going back to Visual Studio, let's close all this stuff. And by the way, I should check to make sure the background I was running my unit tests. Yeah, they're all passing, and yeah, everything is checked in. By the way, there is a link below also to where my code is. It's in 2 levels of Git repos. So the first level will basically just have top level stuff, including 2 manifest files, main and get. Main is what you use if you have an account on GitHub. If not, you can use get. The only difference is the get uses HTTPS, whereas the main uses SSH. And it lists all the second level repositories. So all my code is really in individual repositories that the top one links to through this XML manifest, similar to how Google's Android is divided into many different repos, and there's a manifest file pretty similar to this to describe where to get all those repos. I use a tool that I wrote called Mugget, and basically it will enumerate through. And for example, I'm listing here all of the repos and what branches I'm looking at on all of them. And there's some other commands like adding, removing repos, and yeah, that's what I use. But you don't have to use that. You can just refer to these URLs and then where they go. And that might be useful if you're just interested in like this TLS decorator, for example, here's the link to it. And it's all MIT licensed stuff on GitHub because this is all for fun. And it's all open right now. So anyway, enough of the intro. Let's go look at, let's actually close all this stuff and look at Rover. So Rover has this TLS decorator, but it's got a flaw in it, and that I was just playing around and I thought I would decorate this interface. Problem with this is it's HTTP specific. So the last stream or two, I was reworking this so that instead the new one, which is in its own library now, decorates the more abstract network connection interface that I designed from my system abstractions library. So this should work for things other than HTTP. So for example, SSH or SFTP or RCP, that stuff, right? So we're going to remove this old decorator and then use the new one instead. So removing is not that hard. I just need to go to Rover and go into the CMake list and just remove references to the decorator. And then go in the source and just delete it. Deleting source, right? How do they ever do this? Usually we're adding or changing, but this time we're deleting. And I use CMake to construct my build systems. It's very convenient because it works with Visual Studio, works with Xcode, works with GNU Make, Ninja, a bunch of other things. So it's a meta build system. So CMake builds the build system. So in this case, I changed the CMake list, which is just listing all my source files. So running CMake, it updated my Visual Studio project. So now I'll be prompted to reload it, and when I do, I'll see Rover now is missing TLS decorator. And it won't compile because it can't find the header file, right? So let's fix that. Now the TLS decorator is in TLS decorator / and it's not going to find it either because we have not listed TLS decorator as a dependency. That's also in the CMake list. That would be, instead of relying directly on LibreSSL stuff, we will rely on the TLS decorator. And then rerun CMake again. This should reload again. And now I can find our TLS decorator header. Okay, so TLS decorator is inside a namespace of the same name. And here's our first problem, right? Before, we were creating the transport layer, this HTTP client network transport, and then we were, if it was HTTPS, we would create the decorator and then configure the decorator to decorate the transport. Now instead, we want basically to move this out, or to copy it really. It's the same transport. But instead of configuring the decorator to decorate the transport, we want the TLS to be decorating every connection the transport makes. Which makes me think, instead of creating one, we're going to have to make a function which creates one on demand and give that to the transport. Yeah, so we'll kind of want something like this. Transport set connection factory. And then conceivably it's just a function which returns one of these. Actually, we're going to have to make two things, right? So first, the decorator. And then a connection object. That's system abstractions network connection. And in order to get that, we need to include that. And then we will say decorator configure the lower layer, which is the connection. And then, okay, we need a server name. So let's make that a requirement of this decorator that it be given a server name. And then return decorator. So we won't configure the, we won't do that. So the idea here is we're using dependency injection. We're injecting a factory function. In this case, I made it anonymous. That given a server name, it will return something which conforms to the iNetwork connection interface. And in this specific case, it creates a connection, decorates it with TLS, and returns that. We'll make it so that if we don't call set connection factory at all, it'll use some kind of default factory, which just makes one of these. In fact, it'll just look like, if I were to duplicate this, this would, let's say this is the default factory. We'll make that the default factory. Here, we're calling it explicitly, but I kind of think if we don't care, it should just make one by default, and this could be the strategy for the default. So let's comment that. I'm going to want that code in a minute. To get this to work, I need to define the set connection factory. That's in this transport class. So that class is in its own library where we've been using test-driven development. So I think we should do the right thing and go to that class here. It's unit tests, and I had a test for this. So here we're going to make a test, set connection factory. Okay. So let's make, we actually, probably in these tests, we have a mock client class. Oh, no, we don't. So let's make a pretend client. I mean, a pretend connection. And let me steal from another test. I'm sure I wrote this before many times. Mock connection. Doesn't really matter which one we pick. Not that one. It can't be an HTTP connection. It's got to be a network connection. Ah, okay, here we go. So, whoa. The folding disrupted me. Okay, we probably won't need this exactly, but we'll just start with it. So, substitute for a real connection. Used to test, in this case, the setting of the set connection factory method of HTTP client network transport. All right. Don't know if we actually need any properties. Don't know if we need any of these methods. At minimum, we need something to implement all the virtual methods. Hey, Rally Monkey. Yeah, I'm trying to do that from now on, is start with an intro that kind of gives some context. So, we don't know if we need to capture any of these things, so just reducing it to the minimum. Well, that's not too hard to do, right? Maybe we'll bring that back in. What was it? Peer port, peer address given, peer port given. It's cheap enough. I can do that. Is connected. We can bring that in too. I don't know if we'll need this. Really, we just want to make sure it calls the factory we tell it to call. Pretty sure we don't need any of that. Yeah, we don't need any of this. Probably don't need anything there. So it will be the thing we're testing, transport dot set, what did I call it? Set connection factory. Okay, and then gotta do something. I know. We'll have just a mock connection. We'll just make one, and then we will... Well, hold on. Let's do const auto connection equals standard make shared. Because we're supposed to be making a shared pointer to one. So what we'll do here is we'll say return connection. Okay, and then we need to do something with the transport to cause it to create a connection. So connect sounds good. So connect host name or address. A port number. 1, 2, 3, 4 maybe. A data receipt delegate. Let's see what that is minimally. It's one of these. Return void and take that. Return void. Okay, and then broken delegate. I should have this memorized by now. Takes that and doesn't need to return anything. And that's it, right? Yeah. So we just need a host name or address. How about example.com or something like that? It's going to return something. So const auto, what does it say? I think it's supposed to be an HTTP connection. So let's call this one what do we kind of call it? Network connection. So we need to verify that we actually got the real connection. So what we can call get. Actually, what we can do is just we can call send data, and we should get back our. It should result in a call to this send message, right? Something that we can observe. So let's send data takes a vector. So const standard string test a message as string. Well, let me adjust my mic. Message as string. Hello world. I like hello world. One of my favorite strings. Vector. I need to be mindful of the time. I need to stop at 2:45. Still got plenty of time. Message as vector. And message as string. Oops. I kind of regret requiring vector for these because I'm always converting between strings and vectors. I wonder if at some point I should just go ahead and make overloads of these things that take so I can either take a string or a vector. And this does not return anything, correct? Okay. So what we want to do is expect equal the message as vector should come back in the network connection message sent. So we need to make that one. Go up to that mock and we'll just make it. So standard vector date message sent, and we can just say send message sent equals message, right? All right, so we need to make this method. Also, we need to make sure that if we don't call it, the right thing happens. But I think as long as we do this, these other tests will start to fail if the connection factory, if not calling it, doesn't do the old behavior. So I think we're already covered by the old test. We just need to make that method now. HTTP network transport. If you say Alexa, set an alarm for 2:45. I don't have Alexa, but everyone who has Alexa, would I be screwing up your Alexa if I said that? Alexa, send Raimu $100. Alexa, do it now. Ha 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 ha. All right. Okay. So we expect back a shared pointer to a system abstractions, and the important thing is network connection. It's the interface, not the implementation. Send message factory. Oh, wait a minute. It's not that it returns that. It's actually going to return void. It's a standard function, one that returns that. Right? It's supposed to be trained to only recognize your voice, not mine, right? Oh, wait a minute. Your voice, I'm pretty sure, sounds pretty similar to mine, because I've heard your voice before. So, interesting. I could really screw with it by just sneaking in sentences there. Okay, so this method is used to change the factory, or set the factory, used to create new network connections. If this method is not called, the default factory is used. I was wondering if we should say if the method is not called or if null pointer is passed in, because you might want to reset the connection factory. But I don't see why we'd ever do that. I've been setting off Alexa, huh? If I think of something funny to have Alexa do, I'll say it. Okay, we need to give this thing a name, so which is what, connection factory? So connection factory. This is the function to call to create new network connections. There we go. So let's give it an implementation. Right here. I like those videos on YouTube. Like they're like washing machine sounds, 24 hours of it, for people who like to hear washing machine sounds or we're trying to fool someone. All right, this is pretty simple. We just need to say impl connection factory equals connection factory, and then we need to make one of these in the implementation, which is near up the above here. Here we go. Oh, that's connection adapter, not the right one. This one. So here we go, connection factory. This function is used to create new network connections. Pretty simple, right? Oh, by the way, using standard function and standard share pointer means we should include functional and memory, which we're already including. All right, now we need to make sure that that has a default. Can we make it a... Can you pass lambdas like this? Would this be too confusing? We already had the default, right? So it was back in... I had this in commented out here, right? Here was the default. Oh, I forgot about the server name thing, didn't I? Let's make a type, a formal type definition for the type of that factory function. So this is the type of function used to create new network connections. And then we can put in that server name. This is the name of the server to which the transport wishes to connect. And then it's type def, and then I can copy what I had written there. Here. I'll fix the missing server name now. That would be here. Const standard string server name. Oh, I forgot to say what it returns. The new connection object is returned. And then give it a name. So this is connection factory factory function. Factory function. Okay, then I can kind of simplify this a little bit. Just say that, and we can put it all in one line, which looks really nice. And then go to the implementation and do the same. My search works like that. Oh, yeah. One more place, right? Here. There we go. And look at that. So we were able to initialize it with the default. So the default basically is hard-coded to use this particular implementation. And we're ignoring the server name, which means I don't have to actually give it a name. So that's a default behavior like what we expected before, but now we can override it. We just have to make sure we actually use it. So that will be here. Basically anywhere we reference that class, we need to make sure that we're going through the factory. And let me update this. Note. A different connection object type can be used if the user sets their own custom connection factory function via set connection factory. All right. Oh, that needs to be an I. It could have been an I all along because we don't depend on the concrete implementation, I hope, but only the interface. That's still good. Okay, here, all we need to do is call our own connection factory. Simple, simple, right? Oh, and it's already in the impulse, so isn't it? No. Okay, what's wrong here? Oh, we need a server name, host name or address. There we go. That should be it. There's really not much to it. Now everything should build, and we can first run the client network transport tests. Okay, it didn't build. Things are never that simple. Oh, okay. It doesn't know the type because I'm not including the correct header. Let's try again. Building. Built. All right, so that is HTTP network transport test debug, HTTP network transport test. Look at that, it ran the first time. Makes me suspicious that the test isn't right. Let's both expect that it's equal and expect that it's not equal. A surefire way of making it not work. There we go. So, hey, look at that, it's working. Simple as that. Let's check that in. That meaning the changes to HTTP network transport. And let's say we're introducing dependency injection for creating connections. And this I really should have done before anyway. This is a strong contract saying that this class adapts anything that supports the interface, not just that particular default implementation, right? Cool job. Actually, I'm going to trim this down. We actually never needed what I thought we might need, which is this peer address and is connected. So we can just kind of drop all that stuff. Doesn't matter what we return there. And sure, we're always connected, right? Right. Okay. Just has the message sent. Right, okay, good. So HTTP client network transport. Add make, or how do I say this? Allow injecting network connection dependency. I use those words injecting and dependency injection because you can look up those terms and read more about that general pattern. Or what is it called? Design pattern? Methodology? I don't know. Something like that. Okay, we're good. So let's move on to Rover. We had Rover working. Working compiling. And it actually should work for real, although this is the first time I've integrated these things together and actually done something with it. This we know we don't need anymore. Let's say we just go for it. So I do have to be careful though. Last time I was making connections to secure websites, I was picking sites that were echoing back personal info, so I don't want to do that. Test, oh no, it's just debug Rover, right? And let's just try normal web access. Google.com, right? So we get back a bunch of JavaScript. A better one would be what? What was one of those that gave us a redirect or some simple HTTP? I really should have researched this before. I want to have like a real web server that gives us something plain and simple. What am I doing? Open new window in Firefox, and then I don't know. Actually, you know what would work is if I picked a link on GitHub to one of my own files. How about we'll go meta, so we'll have it peek at Rover. There's a way you can get a URL to just show you the source code, right? It was like this raw thing. There we go. So something like that. Only that, okay, actually that, I'm not sure, that's HTTPS. Let me do this let me do it off screen for just a second to make sure no personal info gets leaked. Let me bring it back on screen because I have a problem here. What happened to my cursor? Okay, there it is. It like disappeared on me. Okay, paste please. Oh, it crashed anyway. But let me try without HTTPS. Oh, well, HTTP works in that if you ask for just an unsecure connection, it responds with, hey, we moved it, you need to go to HTTPS. So at least that's working, but right now the insecure one's not working. Hold on, let me, just to be safe, let me use this tool Postman. This is actually a neat tool. I'll show setting up the request, and then I'll just do it off screen to make sure there's no personal info. But you can say, hey, I want a new request. It's going to be like a GitHub example, raw file content, and then we put it in tests, and we put the URL there. Then here, let me do it off screen so I don't leak anything. And I'm just going to look at the headers to make sure there's nothing bad in there. It looks okay. Yeah, so let me bring it back on screen. This is what we should have gotten back in. Here are the headers, right? So we've seen this kind of stuff before. And then the actual body is just, it's raw text. We could have seen that in the header. Content type text / plain character set UTF-8. And there's the text we get back. So problem is, when Rover's doing it, it crashes. So let's find out why. Let me take that URL, put it in the clipboard, and we'll set up Rover to run. And then in its command line, we'll put that. And then we'll tell it to go. And there's the crash. So what's going on here? Data is received. Transaction was completed and it's closing the connection. TLS close. Ooh. Yeah, here, okay. This is not so good, is it? Yeah, it's trying to join the worker thread, but we're in the worker thread's context, see? So I think what we need to do, I didn't expect this, is if close is called from a callback, so like we're re-entering the decorator to close the decorator, then we shouldn't do this part here. Actually, we shouldn't do any of this part. We'll just set the flag to the worker and the worker will stop itself. Yeah, and then I also want to have it do this close. Probably when it leaves the worker thread's main loop, it should do that. I have to think about that. Actually, I think what it will do is we'll say if this flag is true. Yeah, we'll have the worker thread do this part. And then we'll only do this if we're not in the worker thread's context already. So it'll be like this. We'll say, if this thread get ID is not equal to impl worker get ID, then do that. And then we'll move this up to the worker thread and have it do that when it leaves its own loop. So right here, but we'll only do it if close upper layer closed. Since we're inside a method of the implementation object, we can remove these arrows. Why is it telling me that? Oh. Okay, it goes up a level. There we go. Indentation bug. This delimits the entire structure. That delimits the worker method. Okay, so let's search for where this upper layer closed is used. Yeah, so see how it does this? So we basically have this again down here. So all we really need to do is break. Right? Now, one way or another, we will call this close when upper layer close is set to true. So it'll be either immediately on the close if it's set to be clean and the buffer is not empty, or it'll be later, the worker thread will do it later. Actually, either way the worker thread does it. It's just if it's synchronous stop, like if it's not clean or it's clean but the sand buffer is empty, we'll actually wait for the worker thread to exit, and the last thing the worker thread does, we'll do the close. So when I make that change, I want to make sure I didn't break anything. Hold on. That window should go there. Okay. So make sure I didn't break anything. Let's run the decorator's unit tests again. Okay, nothing broke. Let's try rover again. Again, my cursor's screwed up. Hey, look at that. It worked. That's awesome. So we didn't see it. It's sort of all behind the scenes, but all of that stuff I went over at the beginning about how it works. About how the startup works and how sending and receiving messages works. That's all now done behind the scenes. And Rover doesn't really know much about it, and neither does the network transport layer, because the decorator kind of handles it all internally. So let me show you again how we did that. In Rover, if the scheme is HTTPS, we're setting a custom connection factor. You're basically telling the transport layer, whenever you need a connection, call this. And what this will do is it makes a connection just like the default factory did. By the way, we can look at that default factory again, if I can find it. Where are you, default factory? Right here. The default factory is just make a new connection object, use it, right? So instead what we're saying is make the connection object, but also make this decorator called Tls Decorator, configure the decorator to use that connection, and then it also needs to know the server name in that case. And that's all we really needed to do. All of the extra layer of doing the security is done by the Tls Decorator, and the transport, all it knows is it has a function to call when it needs a connection, and that's it. Pretty sweet. I like the decorator pattern. Let me run. This is like a bug where my cursor is off screen. What if I resize the window? Okay, that fixed it. A strange bug. Let me make sure it still works with the unsecure. Right, so the unsecure says, try again with the secure. Awesome. Cool, I'm really happy that worked. Yeah, okay, cool. Then we're in a good spot actually. I'm not going to be rushed for time. I hear I had to fix a bug, right? The bug was that we could re-enter close from a callback and then end up trying to join our own thread. So we're fixing that. So Tls Decorator. Fix bug re-entering close from worker context. Worker thread context. So let the worker thread do the actual underlying connection close. When close is called, just mark that the worker should stop. Additionally, only if not in the worker thread itself, we can block waiting for the worker thread to be stopped. So it's actually a good point to point out we need this close to be pretty much synchronous because we call it from the destructor. We need to make sure that before the destructor returns, we have no background processes, because things can get really weird if we're still running a worker thread, and the worker thread is either looking at members of this class or or the handle to the thread itself is in that worker thread. I mean, in that class. So on purpose, we need this close when we pass false, basically clean is false, to be synchronous with the thread. We need this code here. Otherwise, weird stuff can happen where that worker thread continues to run even though the class is destroyed. So we kept that, but we're now handling the case where we could be in the worker thread already and re-enter close, and it'll just set that flag, not do this. And then what happens is it'll naturally go to the top of this loop and break out of the loop, close the connection, and then terminate, right? I suppose we could have a race where if close is called twice, we can end up trying to... No. It's not. If it's not joinable, we return. Never mind. We're good. We are good. I'm doing the stream, sometimes I feel like I'm talking to myself. To remind myself that there's at least... Let's see. There are at least two accounts watching me that I know for sure are bots. So at least I'm talking to some bots. So hello bots. How are you guys doing today? So in Rover, we didn't actually change much. We removed the old decorator. That was experimental. We changed our dependencies. Instead of being dependent directly on libSSL, we're dependent on our decorator. We're pulling in that decorator from the library. Hello, human. And here was the difference, right? So before we made the decorator and we told it to decorate the transport. Now instead we're saying transport, when you need a connection, call this, and then what we provide is something that makes a decorator for a connection. So the summary would be replace experimental Tls Decorator with the actual one. And we'll say that Tls Decorator now decorates the underlying network connection object rather than the upper level HTTP connection object. Actually makes it a bit cleaner, and we can reuse it now with non-HTTP stuff. Okay, that should have been it for changes. And I like to run ctest, cdebug, goes through all of our test suites and runs them all just to make sure nothing is broken unexpectedly. Oh, by the way, I showed you these diagrams earlier. I forgot to mention, I mentioned it yesterday, but I made these with this cool thing I found, which is easy to remember. It's called draw.io. And what's cool about it is it doesn't have to connect to your cloud stuff. You can actually just import, like here, I have my stuff here as XML files. I looked at the XML files offline and they look like a bunch of machine interpretable stuff, but not human readable stuff. It's fine with me though, as long as I get back into the drawing tool. It's really neat, pretty easy to use. You can drag stuff around. It's fairly nice, although there's a little quirk. I guess it doesn't like you to return to a context that didn't live as long. But yeah, this is called a sequence diagram. And it does a fairly good job also. Where was it? Also with just general class, what do you call these? Component diagrams, where I'm showing the little stick and ball is a provided interface, and then the hook is the requires an interface. sort of showing the relationship between different objects. So I like this. I could draw it up pretty easily. So yeah, I recommend that site. I wasn't sure if it was the best in class. I asked around and got some fairly good feedback that it was pretty good. So I wanted to mention what I used there. I know not everyone likes to draw these diagrams, but I find them really useful for complicated interactions like this. Then when I'm explaining it to someone, they can they have like a roadmap to see what objects are involved. So here there were 5 objects in one thread. That's what the little arrow thing means. It's a process or a thread, and these are just objects. It's somewhat, what am I trying to say? Somewhat vague, like exactly what these rectangles mean. They're sort of like it's the processing of a function call, but not exactly. Like some things like this arrow for read, that's not actually always sending a message. It's also just accessing. So I may be pushing the limits of what you're supposed to do with this type of UML diagram, but the main most important thing about diagrams is you get your point across. It's more important that you get your point across than using the syntax exactly. So as long as you guys can understand a little bit better what I was doing yesterday and today, how these objects interact, then net gain, right? So let's see. Going back. Yeah, removed the old one, added the new one, did that, so we're done. And great, don't have the time pressure today. I did plan this to be a short stream because I got started late, but yeah, I'm happy that I got this done. So I guess what we'll do next time is I'll be trying to fit this decorator into my web server. So a couple things I'll need for that. So to reuse TLS Decorator, yeah, I still got 15 minutes, so I figure I'll write in my notes plan for the next time. To reuse TLS Decorator for a server, what do we got to do? So we'll need to call TLS server instead of TLS client, right? And so what will we need? For example, I know we'll need a server certificate. So yeah, what will we need to run it in server mode besides client? Need to figure out what we need, and then what else? How to configure TLS Decorator differently, client versus server. So right now we just have a single method called configure, so we'll have to devise a way to be able to say whether it's client or server, either 2 methods or same method with different arguments, right? Something like that. Okay, so on the server side, what else we need to do? I'll actually need to make the server certificate for Raimu.com, which is this is the test domain that I have right now for the web server. And what else? That's basically it. Oh, no, there's more than that. We added dependency injection to client network transport, so we'll need to add dependency injection to the server equivalent of that, like we did for HTTP client network connection, network transport. So I don't know if I'll get through all that in one stream. I'll probably have to do the certificate stuff off stream because, you know, there's secret keys and stuff in there. So probably what I'll do is I'll do that last. And maybe for the beginning, we'll, instead of going to the real server, I'll just do it. I'll just be doing it on my local host, and I'll use a test certificate. You can. There's an easy way to make a test certificate. So let's look that stuff up. So look up how to make a test. They still call it SSL certificate, even though SSL is the old name for TLS. But that's essentially what we need. We'll call it server certificate, and that's also known as SSL, right? Need to look up how to make a test one, and then we'll use that test one with the local host. So this is separate from how do we reuse it. So this is ideas for next stream's plan. And then that, and then that. Okay. And no apostrophe because there's multiple streams. Probably, most definitely we'll be able to get through this. Probably be able to look that up and try out secure connections locally. Don't know about this because I have to do some of that off stream, and there might be some complications. So I can actually tell you guys what I do if you're curious. What I recommend if you're going to get it set up a web server with a secure, ability to do secure connections is you go to Let's Encrypt. Because the certificates are free. The only hook is that you have to renew them every 90 days. And I really never figured out how to go through their site directly. I think they want you to like set up automation to do it. So I ended up going through a different, like a intermediate. I think it was, I need to look up my off-screen notes. Just a sec. Just a minute. Almost there. Zero SSL. I like these guys because it's very simple. It looks like almost like you don't need to know anything technically at all. You just need to know what to drop in what boxes. And I spent like a half an hour figuring that out, and drop the right things in the right boxes, follow the instructions. You have to put some test files on your server, and then it goes and checks to make sure that you basically are the owner of the site, and then it gives you a certificate, and you're done. So if you're looking for services to get server certificates, this is what I use in the past, is what I'm going to probably use in the future for this stream. So I'll be making a certificate for Rymu.com, and we'll be playing around with that. So yeah, I think I'll wrap it up here, and we'll host someone else, and probably be back tomorrow, although it's been very hectic and busy this week. So let me go just check who's online right now. Okay, let's go host Said Who, because he's been a very nice visitor here. We'll go host him. Introduce you to Said Who. He doesn't talk on mic most of the time like I do. He's got music, and he just types. So a little bit more chill, but he's working on Vulkan today. So thanks for watching. See you tomorrow.